Balancing chemical reactions. Chemical equations, word equations, and examples of chemical reactions. All chemical reactions involve changing substances. In a chemical reaction, one or more reactants change into one or more products. It may produce a batch of muffins, or the rusting of iron. It happens when hydrogen peroxide decomposes to form water and oxygen gas. Also, methane and oxygen reacts to form the products water and carbon dioxide. How do you describe what happens in a chemical reaction? The reactants are written on the left, and the products on the right. An arrow separates them. You read the arrow as yields, gives, or reacts to produce. Here's the chemical reaction for baking muffins. Mixing eggs, plus flour, plus sugar, plus butter. The baking them yields, or gives, a batch of muffins. And here's the chemical reaction for burning methane gas. Methane, plus oxygen, reacts to produce carbon dioxide, plus water. Chemists are smart people. They developed a quick, shorthand notation to convey as much information as possible about what happens in a chemical reaction. The chemical equations. Chemical equations are a representation of a chemical reaction. The formulas of the reactants, on the left, are connected by an arrow with the formulas of the products, on the right. Here's the word equation we used for burning of methane gas. That can be converted to a shorter version. The chemical equation for burning of methane gas. Another one. Here's the word equation we used for rusting of iron. That can be converted to a shorter version. The chemical equation for rusting of iron. One important thing we need to ensure for chemical equation, they must always be balanced. For that we must remember the law of conservation of mass. Mass is neither created nor destroyed in any chemical reaction. Therefore, balancing of chemical equations requires the same number of atoms on both sides of a chemical reaction. The number of atoms in the reactants must equal the number of atoms in the products. It was Antoine Lavoisier who discovered principle of the conservation of mass. It means, a chemical equation must be balanced. This implies, it must have the same number of atoms, of the same kind, on both sides. To balance chemical equations, we need to understand how to count the atoms. First, the subscript. It shows how many atoms of an element are in a molecule. Let's consider the chemical reaction of burning of methane. In this case, methane has 1 atom of carbon, and 4 atoms of hydrogen. And the oxygen molecule has 2 oxygen atoms. The carbon dioxide has 1 atom of carbon, and 2 atoms of oxygen. Then, water has 2 atoms of hydrogen, and an atom of oxygen. Next, the coefficient. It shows how many molecules of a particular chemical is involved. Let's continue with the balanced chemical reaction, showing the correct coefficients per molecule. In this case, there is 1 molecule of methane and 2 molecules of oxygen. There is 1 molecule of carbon dioxide and 2 molecules of water. The coefficient multiplies the number of atoms. Thus, for oxygen molecule, the total number of atoms is 2 times 2 equals 4 atoms. And for water molecule, the hydrogen has 2 by 2 equals 4 atoms. The oxygen has 2 by 1 equals 2 atoms. This is an example of an unbalanced chemical equation for the burning of methane gas. The identity of reactants and the products are correct, but the quantities are not. How do we balance? Notice, if we add a molecule of oxygen in the reactants, and also add a molecule of water in the product side, and count the atoms for each element, the number of atoms are now equal. It is now a balanced chemical equation. Let's now learn how to balance this equation by the atom. We always start with the elements carbon, then hydrogen, then oxygen, then the other elements present. Then, simply write the number of atoms based on the subscripts. Compare the left and right atoms. The carbons are already equal, but the hydrogens are not. If we multiply the right hydrogen by 2, both will be 4, they are now equal. Then place the 2 as the coefficient. Notice the coefficient 2 also applies to the single oxygen of water. Thus, we multiply it by 2. The total oxygen on the right becomes 4. To balance, we must multiply the left oxygen by 2. This makes the total oxygen on the left also 4. Then place a coefficient 2 on the oxygen molecule. Compare each atom on the left and the right. The carbons, the hydrogens, the oxygens are all equal. Therefore, the chemical equation is now balanced. Let's try to balance the decomposition reaction of hydrogen peroxide. Again, simply write all the atoms present. There is no carbon atom, so we begin with hydrogen, and then oxygen. Then, indicate the number of atoms for each element, based on their subscripts. Now compare the atoms on the left and the right. The hydrogen atoms are already equal, but the oxygen are not. If we multiply the single oxygen of water by 2, and also multiply the left oxygen by 2, the total number of oxygen on both sides become 4. Then place a coefficient 2 on both the peroxide molecule and the water molecule. Notice that the coefficient 2 also applies to the hydrogens of both molecules. Thus multiply the atoms by 2 on both sides. Compare each atom on the left and the right. The hydrogens, the oxygens are all equal. Therefore, the chemical equation is now balanced. Let's try to balance the chemical reaction for rusting of iron. Again, simply write all the atoms present. There is no carbon and hydrogen atoms, so we start with oxygen, and there is iron present. Then, indicate the number of atoms for each element, based on their subscripts. Now compare the atoms on the left and the right. If we multiply the oxygen on the left by 3, and also multiply the oxygen on the right by 2, the total number of oxygen on both sides becomes 6. Then, place the multipliers as the coefficients. Notice the coefficient 2 also applies to the iron on the right. Thus, we multiply it by 2. The total iron on the right becomes 4. To balance, we must multiply the left iron by 4. This makes the total iron on the left also 4. Then place a coefficient 4 on the iron atom on the left. Now, compare each atom in the left, to each of the same atom in right. The oxygen atoms and the iron atoms are all equal. Therefore, the chemical equation is now balanced. Let's look at how to balance the reaction between nitrogen molecule and hydrogen molecules to produce ammonia. Here's how to balance the decomposition reaction of potassium chloride, which yields potassium chloride and oxygen molecule. Now, here's how to balance the burning of ethane, which yields carbon dioxide and water. Remember, coefficients are always in whole number, there cannot be any half molecule, so, simply multiply the whole equation by 2. Since we multiplied the whole equation by 2, we also must multiply each of the atom by 2. Now compare each atom on the left and the right. The carbons, the hydrogens, the oxygens are all equal. Therefore, the chemical equation is now balanced.